other people can consume. So everything is an API. And when you build such applications, sometimes requirement changes. You need to integrate with other APIs. So you always recompose. So you need agility. Right? This is an hype. So let's look at how you develop applications that are integration heavy. So we used to use ESBs, enterprise service buses, and for the current trends like microservices, serverless containers, they are considered bulky, like heavy, because they take a lot of time to start, and which means they are designed to run for many years, not like containers usually shut down and start when you scale down. So typical ESBs not the solution for modern application building, and also most of them have DSL, so XML, YAML based configurations. So they are, and usually typical developers, they don't like to code using XML based or YAML based languages. It's not intuitive, and also it's not agile, and they don't love ESB, the CI/CD process. The other end of this, so one extreme is to use ESBs, the other extreme is to use programming languages. And so you would consider Java, Node.js, Python, and that class of languages to develop integration heavy applications. Right? So you can do that, but there are several limitations. One is type system mismatches. These languages, most of these languages, they are not aware of the networks type system, network data types. Example, JSON, SQL, XML. So you have to import third-party libraries to deal with JSON, for example in Java. Right? And also some of these languages generally poor at handling asynchronous programming or complex. For example, if you look at Node.js, if you build a complex application, and it's very hard to understand. If you look at it maybe after 6 months. And also writing resilient applications in such languages, you also have to import libraries. For example, you would use histories to implement circuit breaker functionality. And these languages are not designed for modern application building. And so there are two extremes. One is used to enterprise service buses, and the other one is to use languages. So Ballerina, one core design principle is to fill this gap, building integration heavy applications, and also microservices are part of that. So let's look at this session is followed by a set of demos. So I will explain how we have solved this and what are the first class citizens, entities, network data types, and how we have designed Ballerina to handle this class of issues. Right. So as I said, Ballerina is compiled, type safe, concurrent programming language, and it has many design principles. So the syntax you would see in that it's a bit unusual, because in a typical programming language you would see textual syntax. Right? In Ballerina we have both textual and graphical syntaxes. So you can start from graphical syntaxes or textual syntax, and you can convert them in any format. So I have a demo with that. And also the language, we don't try to hide the network. So all the network failures, network data types, network entities like services, resources, they are first class citizens, and all the errors are part of the language. And some stuff like that. The programs you write, we try to make them secure by default. For example, if you heard about the concept called taint checking, taint assertion, taint checking, have you heard about that? So some language, I guess like Ruby, they have compiler checks for basically dirty data coming into the language. For example, using system argument, program parameter, or HTTP request, you can get some dirty data. And if you try to combine that to a SQL query and a database, you get SQL injections. Simple example like that. Right? So this language, we try to identify such scenarios, external data entry, and compiler can analyze and tell you that you get some unsecured data, dirty data, and you have to sanitize and somehow invoke other functions. So when you develop functions in Ballerina, you can basically tag certain parameters as sensitive. So then you can't pass that external data into that functions without sanitizing. So there are some ways to do that. So you have to first do that and then pass. Otherwise the compiler will fail. The other important design principle is the resiliency and how we handle network resiliency. So that I also cover in a demo. So I'll just quickly move on to demos. I'm not sure how to do that demo with this mic, so yeah. Can you all hear me?
Yep.
Yeah. Good. All right, let me first configure. Can you see the text size is okay? Okay. So I'll start with the main functions that you get a first-hand experience about Ballerina.
What ID is this?
So I'm using VS Code, and we do have plugins for IntelliJ IDEA as well. So I would import Ballerina IO package and invoke println, boring example.
What is the engine behind it, like JVM kind of thing? What is it behind it?
So this language is has no semantics leak from Java or any other language, but is inspired from the syntax from Java, Go, Rust, and many other languages. So this language is currently implemented in Java. With compiler, we have implemented the compiler using Java.
JVM.
Yeah, JVM. And it's not a JVM-based language. So usually when you talk about a JVM-based language like Kotlin, when you compile Kotlin, you generate Java bytecode.
Yeah.
Right? That usually, yeah.
So
Ballerina
this doesn't run on JVM.
Is it required?
So the current compile and the virtual machine is implemented on top of Java. So we require JVM, but there's a work going on to compile directly into native using LLVM. Yeah. So we don't have any Java dependency. So we could have implemented this using Go even. Right. So there are two ways to run this. Either you can run the source directly, right? Or you can compile and save. So when you compile, we generate a binary format, and we do have our own specification of bytecode, and it's not related to Java bytecode. We have our own format, and you can either run from there. So an executable file is called balix, and the source file extension is bal. And this is the balix is a binary file, and Ballerina runtime understands and executes. It's similar to Java architecture, right? All right, so that's it. So let's make it a bit more interesting. So we have this concurrency construct in the language called workers, similar to Go routines. Have you heard about Go routines? So I can do. Let's say hello from W1 and copy paste. So this, what happens here is, when you invoke this function, this could be any function, not just a main. When you invoke this function, all these workers are executed parallelly. So this is a static number of workers. So there are some use cases in when you are especially developing applications. For example, the first worker would do all your logic, whereas the second worker will log parallelly. So you don't need to handle that separately. So if I run this, this is just a one concurrency construct. So this will, yeah, you would see hello world printed in different order. So that's all right. So let's look at a service, hello world service. So as I said, Ballerina understands the network and network concepts. So when you are developing a microservice, you're basically exposing a service. It could be internal, or it could be external. So we have just like functions, we have a construct called service in Ballerina, first class construct. And you can say this service is an HTTP service, it's an AMQP, WebSocket, and support protocols. So there are, right now we support different set of protocols. Right, so you can name this service, let's say hello. And also service is a collection of resources, this resource. So in like Java, Go languages, you should have a main entry point. Like when you start, you can run the main. In Ballerina, we have two different entry points. One is the main that I showed you. The other one is a service entry point. That's called a network entry point. So you send when you send a request, you can basically invoke this resource. So that's, and when you, so just import Ballerina HTTP package. All right. So, and also as services, there's a top level concept called endpoints, and there are two kinds of endpoints here in Ballerina. The first kind is a service endpoint, and the second kind is a client endpoint. Service endpoint represent a network entry point, and you can bind, for example, I can say port 9090, and you can bind services to this endpoint. The name of the endpoint is listener. Right? So, but likewise, you can bind multiple services to this endpoint. So this is the entry point to your program, right? And then you can invoke the service for 99, and then this endpoint basically dispatch to the particular service based on the URL or the path. Right? So, and the other one is client endpoint that represent usually the remote APIs, databases, file systems, other backend APIs. So this example, let me quickly echo, right? Implement an echo functionality. So I would create a response, right? And then set a payload and string payload here. So if you look at this signature of this, you would notice that this function accepts string, XML, JSON, and blob. So this language, we have this union type concept. So you can say pipe, and that's a union type. So I would say just set payload string. All right, and then there's this endpoint that represent the caller. That's again an remote, some remote guy, and then you can basically communicate with your caller like this, and with the response. So if you notice that there are these dot and arrows, so dot represent a local function location, whereas these arrows represent a network communication. So we have this distinction between local function calls and remote calls, and there are mainly two reasons. First reason is that we can optimize remote calls, like they handle resiliency, error handling, all that Ballerina runtime can optimize because it knows from the AST level, code level, that these are remote calls. And also, as I explained earlier, we have graphical syntaxes. So these remote calls usually end up like in a sequence diagram. You have actors, and you have current program, your service, and the caller, and maybe multiple other endpoints. So the remote calls usually end up like horizontal lines, like from one actor to another actor. So all the sequence diagram semantics are also leaked into the language, and our graphical syntax is based on sequence diagrams. And you can see an error here because this language we usually we don't allow you to discard return. So if this is a normal function call, this respond return gives an error, and we basically know that we ask developers to explicitly handle errors. If you don't want to handle, you have to declare saying it's unused, like that. Sometimes it's a bit annoying, but on the other hand, usually if you look at IDE, like Java, if you invoke a function which returns something, and if you don't handle it, it highlights it, saying you are not handling. So it's usually best practice. All right, so let me run this.
You have no room for that.
Yes, I think that was here. Nice. So if I run this again demo.bal, and then I'll prepare my curl. So HTTP localhost 9090. So by default, the service name and the resource name is the path. So hello. Hi. So you don't need any other annotations or decorators to specify the service. So that you would see the hello world. So so this is a pretty standard and boring example. It just echoes what it gets. So and you notice that this is a GET request I did, and so there are ways so that you can customize these path segments as well as whether you want this resource to be a GET post, put, delete resource. So I'll just copy paste another example so that it's easier and it takes time. So this copy paste. So this example, if I go back to my slide. So this example, we are extending the previous example by adding a Twitter endpoint. So the caller sends some data as a post request, and we extract that and tweet that directly, right? And then Twitter send a response, and we send the response back to the caller. And we can also extend this by adding some transformations. So you get some data from an external entity, you do some transformation and tweet, and get a response, and again do some transformation and send. So this is the sequence diagram, and this is the resulting code. So I will go through that. So here we have imported the packages /Twitter and Ballerina config. So this language comes with a built-in package manager. So we have some commands built in for you to deal with packages. For example, I can say Ballerina search Twitter, Ballerina search, it's a Gmail connector, some API to connect to Gmail. So all these are part of the Ballerina Central. This is the package sharing infrastructure that we have developed. So this the language is built in with this sort of stuff. So you can search packages that are available here. This is similar to Maven Central, Java program. All right. So you can either, when you search, you can either pull packages, so it will be stored in your local file system, or else when you just import and build, we will automatically download them if it's not available. You can also manage versions via a different, like the TOML file. So I'm using WSO2 Twitter and config. So as I explained earlier, I'm using this endpoint, Twitter endpoint, and this represents the Twitter remote API. So, and you can configure that with some credentials. So this endpoint is part of this Twitter package. It's an abstraction provided by that package. It's sort of a facade, and then that has easy to use functions. So, and then you can pass this configuration, this auth credentials as an external key value pairs. You can pass them as environment variables via a config file, and this config API built into Ballerina can handle all that. And you can extend that by integrating a new third-party configuration store. So this is the TW, this is the Twitter endpoint. So now if you look at this service, and we have decorated that with the service config annotation saying base path is /, and also a resource config annotation with saying path is /, and also it exposes, it's a post resource now. So you get the request and you get the text payload. So text payload and string. So if you notice the check here, this request payload, this function, if I delete this, it complains saying incompatible types. Can you see that? Incompatible types, expected string, found string, and error. So this returns the union of string or an error, because this can fail. So one option is you can handle this as string no error, but then you have to again get the string out. So you could do that via a match. Have like any Rust program? People use Rust. You know a match.
Scala does match.
Yeah. So you can use match to filter out different values.
Yeah.
But instead we have another. So if you're a Go programmer, but usually you would do you put comma error e, and then in the next line you would say if error not equal to null, and then filter, right? So there's another way to do that in Ballerina, saying you can use a check. That's a statement that basically eliminates the error. What happens is if this method gives the value is a string, you just get the string. And in case if this is an error, it basically creates sort of an exception, runtime error, and throw it as this. This is a resource, so this will become a HTTP internal server in this case. If it's a function, different behavior. So that's like construct like that. And then you do some transformations, and then you use the Twitter endpoint, invoke the tweet method with your payload. Here, the payload is just a string here. So if you notice the arrow, it's a remote call, and you get a Twitter status, then you create a JSON like this. So JSON is also built into the language. So you JSON, my JSON equal, open curly brace, JSON field names, and the value. So this payload is this payload, and then status.id and Ballerina. So you can just create JSON and XML part without any other libraries. So you set the JSON payload here and respond. So I'll just run this. So Ballerina run. So I have to pass config twitter.toml. So that toml contains the key value pairs. So if you are client ID secret, and they are required to invoke the Twitter based on this configuration. Right, so I'll just run this. Let me copy the request. So I'll just modify that. Yeah, so if I look at, we have created a demo Twitter account just to show this. Yeah, so you can see that. So that's a simple thing. So that's that. Any questions so far? And then I have another demo. Yeah.
So what happens if in case you have multiple configs? Like suppose you're not doing the footer thing, right? And say if you're dealing with an application, suppose you have a SQL server, suppose you have a SQL server, you have multiple configs. Do you define it in one single config file, or you have to have multiple?
So at the moment, this supports a single config file in this case. So this is particular single microservice would be. So you would have some particular specific task, I would say. So at the moment, we support only a single config file. So but this can be extended to any other third-party configuration server, etcd or something like that.
Also the check statement that you had before, where you said it will match.
Yeah.
So let's say like we have multiple services.
Okay.
So let's say like your
Multiple
orchestrating,
Yeah.
a bunch of things. So will the check, can the check be chained? Like, so let's say service A calls service B calls service C, and like can you chain all those events?
Yeah. So chaining in the sense you would have Twitter. I have an example coming up.
Right.
So you have a Twitter call, some other service call, and that. So you would have individual checks here.
Yeah.
So each check will basically, if it fails, it will. So if you want to do that in a transactional manner, or
Yeah.
yeah.
So like in Scala or like any like functional languages, like there is something called monad. So monad will like using a monad, you can essentially chain all these things together. So if there was a like so if you were writing a Java code, like you will say, hey, like do this class. So you have to like have like a try catch statement,
Yeah.
and in that you call another try catch. Like you don't have to do that.
Yeah. So right now this check is not chained it doesn't have chain semantics like a monad does. So that's yeah.
Maybe we can
Yeah, we can think about that. All right. So I will do the second demo. This is so here. What go back to the So Docker and Kubernetes. All right. So Ballerina, there's a concept called compiler plugins. That's in most languages they do. So we have two compiler plugins, Docker and Kubernetes, and what happens is you can annotate your services and endpoints and all that using Docker or Kubernetes annotations. When you compile, we generate Docker and Kubernetes artifacts of all the YAML files. We can auto-generate. So in order to show that, I'll use this example. Let me copy here. Paste. So the same example, the same Twitter example. If you notice, we have imported the Ballerina X Kubernetes package, and this endpoint that I used earlier. Now I have decorated that with Kubernetes service annotation. So and also this service. We have added a bunch of Kubernetes annotations, the Kubernetes deployment, config map. So what here, when you compile this, when you build this, we generate a Kubernetes service to expose your service as to the external world, and also we generate Kubernetes pod, the deployment artifacts. So apart from that, it's the same example that I showed earlier, the code-wise. So let me build this. So I have Docker and Kubernetes Edge running in my computer, so I can. So let's say Ballerina build. When you build demo.bal. So when we run the compiler identifies compiler plugins, and these compiler plugins they look at their specific annotations and code, they analyze code, and they generate these Kubernetes and Docker. So if ls there's a target, and if I tree the target directory, you can see under the Kubernetes there are Kubernetes deployment and service and Docker file all generated. So if I go back to this, for example, deployment.yaml. So it auto generates all these files for you. So you can just say kubectl minus f Kubernetes. Sorry. Command line is, yeah. Yeah, so now if you say kubectl get pods, you would see the creator Ballerina pods and the SVC, you can see the service. If I, yeah. So the demo is hosted this port 3132640. It's a Docker container. So I can access that from here. So if I open demo resources here, it should be 32646. No, some maybe port. Anyway, we can't see the port correctly. 32646. It's correct, right?
Yeah.
So maybe some, it's running here.
But that's the port in the container, right?
Yeah.
You have to talk to 1919 players.
But if I talk,
Maybe to the node IP because it's the node port.
Yeah.
The port is open in the.
I should use node IP.
Yeah.
Okay. So 10 dot
And then, yeah.
109
24646.
247 dot 3. And then the other port.
Yeah.
32. Anyway, that's fine. So, so what this does is it. So you can see that it's deployed somehow, and so I can let me quickly delete that. Yeah. So that's that. And the next example, next demo, the last one, I guess. Okay, so before that, we'll move into the graphical syntax. So I was using the textual syntax. So we have this tool called Composer. That's part of the language distribution, and also we have integrated this to VS Code, and I think I integrated that to IntelliJ IDEA as well. So what happens is you can start typing code, and we can generate the sequence diagrams for you, the graphical syntax. So let me copy paste one example. So this example is this example. So caller, the service, and the Twitter endpoint. So I think you can see that. So this is the same code. And when you copy paste, it generates this your caller default, and I forgot it has another endpoint, the backend endpoint, Twitter and a Homer. So if we look at code, you can see those two endpoints, the backend client endpoints. So now if I add another endpoint, for example, say from the code line, I'll make it 2. And then I'll use it here. So let me copy this, and let's say I'll use it at the end. Generate response 2 from the Homer 2. So if you look at the diagram now, you can see this Homer 2, and then same get code from here. First one is this API, second one is this. And also you can generate, for example, start from here, while, and then you can see basically while is generated. So you can start from this end and that end, so it's all parity, it's all equivalent. Yeah.
Do you have any Amazon-based packages that you import and use?
I think it's, so this language we released like this last May, so still evolving.
Right.
So we got some packages for Kafka. We have developed packages Kafka and popular APIs like GitHub, LinkedIn, Facebook, Twitter, and also like enterprise Jira, all that. So we are like Amazon S3
Some APIs that you're working.
yeah.
Oh, okay.
And also we are trying to get the community to help us to build packages, and so they can share their packages. Yeah. So that's that. This is the graphical and textual syntax that we have. So the graphical syntax is based on sequence diagrams. So if I, then other example would be if I have a function here, let's say any other function, and I have workers, I think W1, I'll copy these workers. So workers are also an actor or a lifeline because they represent thread of execution. So I'll put some while these loops here. So you can scroll down. You can see this function. The name, I'll change the name here quickly.
So is it the other way around as well? Update the sequence diagram and this code as well?
Sorry?
Is it the other way around as well? If you update the sequence
Yeah,
diagram?
yeah, you can do that. So from here to the worker, I can say add a try catch. And then if you go to the code, you would see that try catch worker one. So it's both ways. Because it's everything you write in Ballerina, we can generate a diagram. The syntax is basically designed in such a way that we can generate the graphics like that. So okay. So that's that. I'll move on to the next one. Okay. So this example is observability. I'll come back to that. Circuit breaker. So when you develop network integration heavy microservices, you need to think about the resiliency aspect, error handling, all that. So one such example would be circuit breaker. So for example, this Simpson code API or the endpoint, it's developed by us for this demo purposes. So when you try to access, when you try to invoke this API, half of the time you will get very slow response time, and half of the time you get very normal response time. So the reason is this is to simulate that usual network interactions. Sometimes if the backend endpoints are slow, they might get not responsive. So you have to handle that in your code. So how do you handle that? One approach would be it's called circuit breaking. I think you all know that. So after a certain timeout, you open the circuit. Basically, you're saying I'm not passing any request to that API, and I do that for a particular amount of time, and after that I retry. If it fails, I do that again. But if retry works, I close the circuit, and the request, I can send the request. So this example, let me copy. Has two endpoints. So basically collapse this. One is Twitter, previous one, no changes. The other one is the home API. This is the URL. So this endpoint, we have configured the circuit breaker functionality, and also additionally we have put a timeout. And so you have timeout, 5 milliseconds, and then circuit breaker. So if there's a single failure, we open the circuit here in this case, and then we retry after 3 seconds, and then we take errors like 500, 501, 502 errors. So this is a typical circuit breaker functionality. And the other thing is now, let's say this is Homer. So you try Homer, the get code method action, and then you get a response. Now this response can be the actual response or an error. Error in the case because of the circuit is open or any other error. So now you can use this match. Basically this is a type switch, usual switch case in programming languages, but in this case it's a type switch. The switch is based on the value, the type of the value. So if the type of V is HTTP response, that is a expected response, then you handle that. You basically get the status, tweet and all that, like you used to do in previous example. In case if the type of the value is an error, then this could be a situation where the circuit is open. So you can handle that error. So in my example, I've just respond to the customer saying circuit is open and invoking the default behavior. So I can, let me try this. Ballerina run. So I'll just get the request. Sorry, I had to use the config. This. So you get a text, so that means tweet is okay. This tweet was also okay. This one is also good. Now, yeah, the next time the circuit is open. Now, I think if you try again for up to 3 seconds, this will be open. And then after 3 seconds, you can try and the code will retry. So likewise, there are other resiliency things that are built into these endpoints. So that's why we have this concept called first class or the top level concepts like endpoints, services and resources that you won't see in a typical languages. That is to handle special or a certain class of problems in Ballerina. It's a general purpose language, so you would see you have all the types. So I would say if you go to Ballerina.io, that's our site, and there's a section called Learn, and then Ballerina by example. So you would see, yeah, so you would see all the examples from Hello World to packages, functions with optional parameters like Kotlin and other languages, and then REST parameters, values and types, array maps, records, tables. The table, we have a first class type called table, and that you can create in-memory table, you can create a table from a database, and then you can manipulate that. And union types, optional types, Java optional types, and then nil lifting, tuples, flow control, basic stuff, error handling, testing also built into the language, JSON XML, network aware data types, and objects, concurrency constructs, fork join, worker interactions, async functions, locking, concurrency constructs, and then function pointers, lambdas, closures, and functional iteration. Transactions are also built into the language. So if you look at the local transaction example, we have this syntax. Where is that syntax? This thing. You can't really see because of the resolution. Yeah, somehow here you can see the transaction block. So we have a transaction block, retry, fail. So it's also a part of the language, like try catch, similar to that. Yeah, and then stream, security, the chain checking examples, and also from Ballerina services and resources, you can generate Swagger, or you can generate Ballerina source code skeletons using Swagger there are commands, Ballerina commands to do that, and also other HTTP, the supported protocols, gRPC, WebSub. Yeah. So it's a fully general purpose programming language, but handles integration heavy application development very well. So that's the target. Any questions? I think that's what I planned for the demo. Yeah, I'm not covering the asynchronous ones. Yeah.
No.
Okay.
It's
Okay. So, yeah, if you're interested, you can just go through ballerina.io site and look at various things. And also, if you want to check out source, it's GitHub, the Ballerina dash platform. Underneath, you would see Ballerina lang repo, so you can check out the code, the implementation. And also, if you have any questions, you can use Stack Overflow channel. And another thing is the first ever Ballerina Con coming up in this July, and I think Hassan will send more details to that later with the promo code. So if any of you guys are interested, I think you can join that. Let me fill that up. Yeah. So first ever, it's a one-day event. We're starting small, and there are a bunch of sessions. So a full-day event. So you can, if you're interested, you can attend that. It's in San Francisco. So I think that's it. Any questions? I think it's late on a sunny day. Both a sunny day. Thank you.